Welcome everyone to the Power Up AEC Collection webinar series. My name is Bobby Del Rosario, host for today's presentation. I am the manager for infrastructure product marketing here at Autodesk. And today's presentation is how Windover Construction and Walter P. Moore deliver with the AEC Collection. Before getting started, I'd like to go over some housekeeping items. First of all, a safe harbor statement that give you all a moment to just read through. I'm not going to bore you by reading through it. And then just some webinar logistics. All of you today are joining this presentation and supported through your computer speaker systems. If you do have any audio issues, please do try to refresh your browser or switching browsers. Also important today, we are taking questions throughout the presentation. You can submit those questions by typing them into the question section in the control panel, and you can enter those questions at any time. We will be addressing them online throughout the session, and then we will have a live Q&A portion at the end where we will be picking out some of really key questions that you submitted today. And finally, we are recording the webinar today, and we will make that recording available to you at the end of the event via email. So with that, I'd like to start with a couple of polling questions. Let me just launch this first one. The first poll we have here is, what best describes your company's primary focus? Architecture, building engineering, civil engineering, construction, or other. And I'll give you folks just a couple of more seconds to reply. Great, I see answers kind of still coming in there. Give it a couple more seconds. All right, let me close the poll and share the results with you. So it looks like we've got the bulk of you, 30% are in civil engineering, and then roughly equal around architecture and building engineering. So thank you very much for that. Let me launch our second poll here. So what is your level of familiarity with the AEC Collection? Haven't heard of it, and we don't use Autodesk products. Haven't heard of it, but we use Autodesk products. Have heard of it, but don't use it. And finally, we do use the AEC Collection. So again, let me just give that a few more seconds. Okay. Thanks so much. Again, sharing the results here. That's great. Looks like more than half of you use the AEC Collection, and glad to see that here none of you haven't heard of it and don't use Autodesk products. So it's great. Thank you so much for that. Let me just get back here. Great. So thank you. Now that we got all of that out of the way, I'm really eager to introduce our presenters today, who are really excited to share with you how they use the tools in the AEC Collection, such as Revit, Civil 3D, AutoCAD, InfraWorks, on their projects to make their projects more efficient, really enhance innovation, and improve collaboration. So with that, let me introduce our speakers for today. First, we have Amir Raafat, Vice President of VDC and Technology at Windover Construction, and Todd Rogers, BIM and Graphics Manager at Walter P. Moore. So I would like to hand the floor over to Amir. Give me a second here. And Amir, you have the floor.
See the screen. Hello everyone, thank you for joining us today and taking time from your very busy schedules so we can share with you what we've been doing with innovative technologies, including technologies offerings from Autodesk Collection. My name is Raafat. I'm a VP of VDC and Technology at Windover Construction.
Can you see your screen?
Okay. Share screen. I'm gonna try to share my screen right now. You can see it? Cool. So maybe if I go full mode, you see it now?
Yeah.
Cool. So we start. Windover Construction is a leading construction management firm. We are 100% employee-owned ESOP. We do construction management and design build projects, academic, life science, healthcare, senior living, commercial, and high-end residential. We utilize VDC and technology innovative solutions to tackle almost all of our project challenges that we have on site. Technology and the VDC is not just a tool at Windover, but it's a process embedded into our daily processes to help us build better and safer. As you see here on the screen, these are a few examples of our projects with life science and academic projects. We'll jump into our agenda today. We'll talk quickly about modular construction, how we transformed that with combinations of drone mapping, laser scanning, and BIM. We'll talk about verification of as-built details. That's a great example for someone who's doing historic renovations, which we do all the time with our projects, utilizing BIM and laser scanning. We'll talk about how we can support the projects at post-construction phase, even after the project is being completed, utilizing drone mapping, virtual reality, and 3D Studio Max in an innovative way. We'll talk also about the future and what the great things we can do together to help build better and safer. So we'll go through how we've been transforming modular construction and prefabrication. Canvas, this is a case study of one of our projects. Canvas, it's an upscale mixed-use apartment complex building in Beverly, Massachusetts. It's 153 square foot with 184 modular boxes. Windover is a leader in modular construction. And this project is, as you see here, the first 2 floors is steel structure, and the upper 4 floors are modular construction boxes. The challenge we had here with this project is how to help coordinate that on site with 2 different structure types. As you see here, the scale of that project, as I mentioned, 184 modular boxes on site in Beverly. The challenge here was the first two floors were steel structure and the upper floors are modular. The first 2 floors were coordinated through a regular MEP coordination process with a plumber. We modeled all the plumbing elements in Revit, and then coordinated that in Navisworks, and the upper floors boxes were made in the factory that's making the boxes. So how to coordinate between both and make sure that the vertical shafts will fit perfectly and we don't have any surprises on site when we bring those boxes. So we made sure we place those boxes virtually first before we bring them on site, so they fit on the basically the lower 2 floors with a steel structure. How we did that? By combining BIM coordination with drone mapping and laser scanning in real time. As you see here, we use every day on our sites at Windover drone mapping and laser scanning. What we did in this specific case, and we've been doing in our modular projects, is that after the erection of the steel of each, we did this on 6 phases. After we erected the steel on site, we fly the drone in the same day to capture the as-built steel from above, and supplemented that with laser scanning from below with a scanner, ferro scanner that is every 70 meter, only 3 millimeter off. So the accuracy is there. And then we combined both in Autodesk Recap Pro, the point cloud, to make sure we have all the information from above, what the drone can capture, point cloud captured by the drone with control ground points for accuracy, combined with the information we have from below with the laser scanner in Recap to do clash detection with and detect the conflicts not only with a model created from drawings, but with as-built steel that's on site. For example, what we see here all in the screen, the red box here is what the factory was planning on putting the slab cutoffs for the vertical shafts, for the upper floors, for the boxes. And what you see in white is the point cloud captured by both the drone and the laser scan. And what's circled here in yellow is the potential conflicts that we detected early on in the process and communicated in real time to the factory, so they make the adjustments to make sure when they make the vertical shafts, it will perfectly not clash with any steel down below or with any piping. We started the whole process, of course, in Revit, modeling all the steel and the MEBs. We also, as you see here in Navis, made sure we, in real time, take all the point cloud that we captured with the drone and the laser scan in the same day, overlay it with the plumbing planning we had from below, and do the overlays in real time in Navis. That helped us reach a zero clash when we brought these on site. As you see here, this is a part of our daily clash reports, which communicated in real time. Again, the time is a very big factor, because when you have a boxes made in the factory and the steel is getting erected, the best way to meet the schedule is utilizing this technology in real time. Drone mapping, laser scanning, constant overlays in Navisworks, Autodesk Navisworks, and ReCAB to make sure we communicate these clashes in real time. As you see here, we detected the vertical shafts locations. And so we made sure when we place those boxes, they fit perfectly and all the MEBs are aligned. To enhance communication in real time, we always been communicating this Autodesk ReCAB web-based simple to use links with our design team, with our field team and the client to help them to have at their fingertips in the trailer or anywhere they can make quick measurements and review the site at any point. We also, at the end of the project, hand the client web-based links from Autodesk ReCAB, so 10 years from now they can see what's behind the walls, what's behind the ceiling for future facility maintenance. So at Windover, we begin with the end in mind. We make sure that we document all the phases, even especially with boxes, like in the factory. We make sure we document each box with its name or number and hand that to the client so they see how these were built over along the way. Another innovative way we utilized the Autodesk Civil 3D is that we used Autodesk Civil 3D to help detect areas and monitor and analysis the facade alignment and do the modification to strapping thickness or the grid size to eliminate issues as the slider went up and down for the building envelope to help deliver a best-in-class facade that's very smooth and preserve the design intent. How we do that? We laser scanned the facade with, again, the scanner that has every 70 meter, only 3 millimeter off accuracy. We scanned it and we took that point cloud from Autodesk ReCAB Pro to Autodesk Civil 3D. Autodesk Civil 3D, we use it every day with the data we collected from the drone or from the laser scan for spot elevations for topographies and to create contour maps with all the information which we collect every day with our drones and our laser scanners. Here, what's innovative is that we consider the facade as a contour, as a plane, and we were able to detect the spot elevations on the facade to make sure detect the areas that need attention from our facade team. As you see here, where areas has pluminess to help resolve that and end up with a smooth facade best in class. So that's another way of how you can, how we used laser scanning with Autodesk Civil 3D to make sure we end up with a high quality product. So the result for this case study of Canvas in modular construction, combining drone mapping, laser scanning, and BIM, utilizing Navisworks, Revit, Autodesk Civil 3D, and ReCAB Pro, and AutoCAD and ReCAB Photo to process all the data, the georeferenced data we have from the drone, helped us end up with zero clashes on site, real-time BIM coordination. It's all the real-time when you fly and capture this, constant overlays, communicate with the factories that makes the boxes and our field team to make sure we mitigate risk in real time. Preserve the design intent, maximize square footage for owner. When you fix a clash early on in the process before they become a problem on site, we make sure that we protect our owner square footage and make sure we don't need to reduce any sizes for shafts or maximize, make the sizes bigger. So we were able to preserve the design intent. Also, detailed future facility maintenance data by providing the client easy-to-use web-based links that doesn't require any training, which is the Recap Pro links, which we've been working greatly for many of our clients when we hand at the end of the project what's behind the ceiling, what's behind the walls, when we scan that and hand them that for future facility management. We'll jump into verification of as-built structure. See, this is something we do. We work on many prestigious historic preservation projects in the US. So what we've been doing is that we're utilizing constant BIM and BIM with laser scanning overlays. As you see here, this example in this academic building, it's a historic preservation one. As you see here, we did laser scanning for QA/QC during construction. Almost every week we go scan the process, and then we do constant overlays in Revit. So we have the point cloud in Recap Pro, and then we take that into Revit. And what you see here in red, for example, is the model, the design model, the structural design model. And we do overlay with what you see here in a realistic view, which is a point cloud scan of the condition on site, the as-built. Then it helped us detect in this example, and there's so many examples, the pier is a little shorter than it should be. Well, when we scan, say in the morning, communicate that with our great field team, same day, they were able to communicate that with the foundation trade partner and help resolve that in real time. That's a great example of laser scanning, of drone mapping, constant overlays in Revit to detect the conflicts and help visualize them and communicate them across the project stakeholders. As you see here, real-time QA/QC define the visual communication in the field. There's no way you can figure out this in 2D. It's all the Revit model overlaid with a point cloud, and then it's very obvious to detect all these clashes or all these disappearances in the process. Early conflict detection, which basically is very helpful. Then we talk about post-construction solutions in an innovative way in a light study. We're using drone mapping and virtual reality, which is 3D Studio Max. So Windover built a state-of-the-art sports facility in New England. And an unforeseen challenge became on site that this beautiful stadium with its bright lights at night games, the light is too bright for one of the neighbors. So the client wanted, of course, to make the neighbor very happy. So they reached out to us, hey, Windover, how we can resolve this? Do you have idea? We immediately fly the drone above the entire surroundings of the site, captured a very accurate, using ground control points, very accurate 3D model drone map of this site. And we did a light study in 3D Studio Max. So we brought the drone mapped model into 3D Studio Max and made light study, how we can block that light. As you see, this is recap photo where we processed all the drone data. What we did is that we modeled the light from the cut sheets as in Revit, and we took that into 3D Studio Max using all the powerful tools in 3D Studio Max Light to simulate the exact light intensity and hue and make sure we simulate that in VR. And tried, evergreen trees in VR, how we block that. We used the shade idea, and that all helped us in a couple of days to very quickly, non-disruptive, find a solution, know exactly what solution we will use to block that light, how much shade we need to order, and things like that. So this all helped us to find the solution, and we were able to locate that exact shade and its location in relationship to the existing building that we built to offer a solution. That's a great example of combining drone mapping with VR in 3D Studio Max to do light study to resolve an unforeseen situation that is actually not construction or design. It's actually happened after construction is done, but that shows how we can utilize Autodesk technologies with VR, with drone mapping to help and support our clients even way after the project is completed. At any phase, support our owners and our clients. So efficient, non-disruptive post-construction solution and significant time and cost saving by eliminating a trial and error approach. Imagine if we didn't do that, we'd go at 10 p.m. at night to simulate a night game, and they bring big trees, evergreen trees, and see how we will block, how we locate them for position, or bring that sheet, we get to order them. So we didn't have to do all that. We did all virtually in virtual reality using 3D Studio Max and the drone map model. Let's go to the future and see what we've been doing and we can do and continue to do to help us build better. For example, robotics. You know, what I talked about improving on-site coordination, as you see here. This one of our projects. It's a Standish Hall at AEC College, one of our Windover projects. If you look at that building, it's really hard to recognize it's a modular building. It's unique features. It's design. It's beautiful design. Our improvement of our coordination process, utilizing the technology we have with drone mapping, laser scanning, and BIM, will provide much more confidence for our designers and our great architects who design buildings, and give them the flexibility so they can design masses and the modular projects that doesn't necessarily have to be simple, because we know how we're going to coordinate that on site. So we took the initiative to really utilize different technologies like drone mapping, BIM, laser scanning, and robotics, which I will mention now, to help resolve that and help support our design teams in design intent to make their designs happen and feasible through BIM coordination. Another way we try to help build the future and transform the construction future is that Windover Construction teamed up and partnered with RCML, a great robotics company that do great softwares for robots. RCML and Windover worked together with the support of Autodesk. Actually, this idea was all born at Autodesk Technology Center in Boston. We both are residents at Autodesk, RCML, and Windover. So what Windover and RCML partnered to do is a robot that would do all-in-one solution for construction, laser scanning, and wall and utilities layout. So what it does is that RCML developed a great software that could help do autonomous laser scanning. What we do, it's a very sturdy design, can go 45 degrees. It's built for job sites. As you see here, it can move from a predetermined target. It's very simple. Anyone on the job site can do it. You know, when we come in the morning, we place those targets here on site. Those targets, it's only for the robot to know where to stop. They stop there and scan 16 minutes, move to the next one autonomously, and at the end of the day, our team takes these files from the stick in the file scanner and process the files. This is not replacing anybody work. It's only supporting our BIM and reality capture teams to focus on what really matters, which is creating the models in Revit or processing them in Autodesk Recap. It's say in a very cold weather like in New England these days, or a containment area, we can send that robot, do the scans, and our field team or our BIM teams process the data. Right up until now, in order to laser scan a building, you would have to go outdoor 16 minutes or indoor 9 minutes to scan at each round and wait, doing nothing, wait until it scans. So it's saving us time in that aspect. Another very powerful solution, that's why I call this all-in-one solution, it can do an automated walls and utilities layout. It takes straight the AutoCAD files from our trade partners, plumbing or walls, simple AutoCAD files, and it can translate that to spray it on the floor very accurately. So that's another way of supporting this. Up until now, again, we would have to have a carpenter measure from different areas, and a building that would take 3 days for someone physically with a traditional method to lay out a building. This robot can do it probably in 6 hours, automated. So that effort, that collaboration and partnership between Windover and RCML and with the support of Autodesk is really going to transform how we do laser scanning, how we do reality capture, and how we do layout, and other solutions that will come through that collaboration to really help transform construction, build better, safer, and let our teams focus on what really matters. That will all help transform modular construction, because as we mentioned before, we are transforming modular construction through BIM technology and laser scanning and drone mapping, and robotics will play a big part of that to help build more modulars. Modular is not only good for quality because it's a building setup. You build in a quality controlled setup in a factory, but it's also greener, and it's the future being greener, and it should be happening right now. And that's what Windover really cares about with RCML, our partners, and of course Autodesk. I'd like to, so this is empowering our VDC, this automation of construction BIM relationship with the field, empowering VDC and reality capture teams, enhancing safety in cold and containment areas, scanning accurate indoor and outdoor layouts directly from Autodesk AutoCAD. So to recap, this is all made possible by AutoCAD, for example, like for this robot layout or early drafting. With many of our trade partners use AutoCAD to lay out their trades. Recap Pro to process point cloud from laser scans and from drone mappings together, all in Recap, whether it's a Recap Pro or Recap Photo, which is a very powerful to process the drone data we capture every day. Navisworks Manage for help with MEP coordination and BIM coordination to help make sure we detect the conflicts early. Autodesk Civil 3D, where we use almost every day to do spot elevations and make sure we track the topography of especially during demo phases, which we do a lot of that for big projects. 3D Studio Max for 4D animation to help tell a story of a project, how we communicate, the project evolve from foundation to steel to building complete, not only with our trade partners or our teams, but also with clients who are not as good as we are in visualizing what in 2D and 3D. So we help the 3D Studio Max heavily. And you saw the example of how we brought the drone mapped model into 3D Studio Max to do something like light study and communicate that in VR and Oculus to the client. Revit, which everything starts in Revit. Creating the model, detailed BIM, information-rich models, it's all in Revit. And that's where we start. Thank you so much for your time. And thank you, Bobby, and looking forward for your questions. Thank you.
That's great. Thank you so much, Amir, for sharing those examples of how you used tools innovatively, helping you to really enhance efficiency in your project, determine best designs to deliver your solution. So thank you so much. So with that, I'd like to now hand the floor over to Todd Rogers from Walter P. Moore. Give me a second here. And Todd, you have the floor. Todd, you may still be on mute.
Yes, thank you. Thank you. Wow, what a great presentation, Amar. Appreciate that. That was very inspiring. Mine is a little bit different approach. We're basically showcasing a large job that we did out in Camp Strake here in Texas. And what this job really did to push our team to use the AEC collection to its full extent. So with that, I'll go ahead and get started here. Let's see. So a little bit about me. I got 10 years working with Autodesk for a value-added reseller. 26 plus years experience in the civil engineering industry. I'm an Autodesk Expert Elite, secretary on the board of directors for Augie, and I'm an Autodesk certified instructor. So Walter P. Moore, who are we? So Walter P. Moore started back in 1931. When Mr. Moore sold his Stutz Bearcat he received as wages, this year was also the Great Depression, which entered the 2 worst years. So he was making $5 per client. So challenged by that survival in the 30s, the company grew by long-lasting relationships with architects and clients. This turned into Walter P. Moore designing the world's first dome sports stadium, which we know as the Astrodome. That put Walter P. Moore on the national stage in 1965. In 1966, Walter P. Moore's structural engineering made Walter P. Moore. And in the 70s, civil and traffic engineering actually came on board. So now with 20 offices and 5 international offices, Walter P. Moore has over 700 employees. And some most recognizable to date, as you will see, we are very strategic in the stadium realm. The ones shown here are just a few that we do. Now, there are many more, including the Las Vegas Raiders Stadium and the fabulous Las Vegas, Nevada, you may see on your way from the airport headed to Autodesk University. So now we can take a look at this Camp Straight. So Camp Straight is a 2,816-acre Boy Scouts of America facility located in the heart of Sam Houston National Forest in Cold Spring, Texas. The camp at an approximate cost of $68.5 million, which will open up this summer in 2020. So this project is the largest development in the history of any local Boy Scout council in America. This camp is comparable to a university campus or a small city. Camp Straight's facilities include 4 miles of road, domestic water plant, wastewater treatment plant, 11.7 miles of trails, 122 vertical structures, over 150,000 square foot of facilities, 20 campsites with pavilions, 450 capacity dining hall, headquarters building, a STEM center, a shooting sports complex, which includes rifle, shotgun, and pistol ranges, also archery and sporting arrows course. There's 12 modern restrooms, shower houses, climbing pavilion, a wild hex ropes course, zip line, climbing and rappelling tower, bikes and an ATV area, 19 training and merit badge pavilions, aquatic center, swimming pool, 28-acre lake, a sports field, a basketball court, ceremony site, 1,200 people arena, 3 chapels, 40 summer camp staff huts, summer camp staffing training building with lounge and laundry room, 4 32-person capacity dorms, and 4 8-person capacity cabins, and more. So you can see it's quite a large facility. So surveying this heavily wooded 2,816 acres would have been a very extensive cost range, obviously. So there wasn't very much means to get in there and do surveying to begin with. So LiDAR was used using the Esri Collector for ArcGIS app on an iPad. So there was no local survey control, and because of the density, obviously it was not financially feasible to get this survey. So this app allowed the contractor to find their location based off the overall site layout. Within the app, they could pinpoint and locate could be accomplished, getting the precise location of the design that was done in Civil 3D. So this allowed the guys to get out there and find out exactly where these buildings were located based off this app. And then they could, get the machines in there, get everything prepared. And obviously we're doing our design in Civil 3D at the time. So more of the challenges that we faced, now the site was laid out and the location of the facilities was determined, the design of the site could commence. So a few major challenges faced was design was the endangered species habit. The existing road had to be realigned in Civil 3D to avoid the disturbance of the natural habitat. Another challenge was the proposed lake. Excavation of the adjacent hillside to fill the bottom of the lake was graded, and earthwork calculations used in Civil 3D was established to site the dam for the lake to avoid the United States Army Corps of Engineering jurisdiction stream. Civil 3D was used to export out the digital elevation model for upload to excavators used in machine control. So how did Camp Straight lead us to use this AEC collection on a daily basis? So instead of LiDAR, we could have used Recap Pro with a drone, produce more accurate survey data. We have since started using Recap Pro heavily and have a list of vendors on hand whenever we need to have a site flown. We could have used InfoWorks to lay out a preliminary design and preliminary cost of construction of the road and lake, then tweaked it in Civil 3D. Alternatively, we could have pulled the LiDAR straight from InfoWorks as well. We now use InfoWorks in some sort of way on almost every single project we do in this office. whether it's just to pull LiDAR for a new project or a preliminary layout of the site to get the feasibility studies. So with the help of Autodesk and its employees, we've started to use this AEC collection more extensively in production. We've assessed our software library and found some software that's no longer needed because we use the AEC collection now. We've sped up production thanks to the collection and cut a big percentage of rework out. Now with the help of BIM 360 for Civil, we are headed for more savings and faster production of bigger, more complex projects, which one is the Walmart home campus. So one of our most recent projects here at Walter P. Moore is we're working on Walmart's home project, or excuse me, our Walmart's home office campus. You know, this is comparable to Google or Apple campus. So with the start of this, its roots being in Bentonville, Arkansas, it only makes sense that its new campus be located there. Along with the use of the AEC collection and BIM 360, we are moving forward and meeting deadlines that would have never or been very hard to achieve in the past. The use of these two have made design changes and collaboration a lot easier. This project is just a start to a very successful beginning at taking on more projects at this level of design. Utilizing the AEC collection to its full potential will make design and collaboration a smooth and seamless procedure for all of our future and present projects. So having said that, on this Walmart project, I did a very neat little operation here. So I used InfoWorks to bring in the SketchUp models from the architect. So what I did then is I exported this out into 3ds Max Interactive. It used to be called Stingray. So this is me actually with a Xbox controller recording my screen. So driving around this campus allows you to see how difficult it would be to make some of these turns and also to see certain areas. So one of the buildings may affect the look of another building, or, you know, like if they needed a building and you couldn't see it very well, you can see that. So not only can you use a car in this, you can also have a guy running around with a little gun shooting tennis balls. So that's kind of neat. But I figured a car would work a little better. Makes more sense since we are doing the design of the streets out there. But you can see all the buildings, how they're laid out here. You can see from a viewpoint which buildings are not visible by other buildings. So if those buildings need to be tweaked in some sort of area, you know, you can see it here live with an Xbox controller. So that's one of my favorite parts of you know, being in this industry is I get to play games with my design, so it's kind of cool. So in closing, Walter P. Moore has come a long way on how his work is handled and pushed through. So now by using this AEC collection, not only has the AEC collection helped with speeding up our productivity and making collaboration easier, it's become a daily tool to sustain our image as one of the leading firms in technological advancements. We look forward to utilizing more of the AEC collection and integrating all the latest and greatest that Autodesk has to offer. So with that, I will hand the speaker back over to Bobby, and thanks everyone for joining. I hope you got a lot out of this.
Great. Thanks so much, Todd, for sharing those examples, sharing how you make, you know, better design decisions through your visualization and simulation, be more environmental conditions, and then improve collaboration. So thank you so much. So yes, I see Amar is back on the screen. Let me turn on my screen, and I will take control back as well. And I would like to start Q&A session. And for that, I'd like to ping a couple of people who've been helping out on the background here. So Aaron, any questions? I'll start with you that may have come in that we can Amar or Todd to respond for us.
Sure. The first one is for Amar. There's a couple of questions related to how the scanning is actually done. So I'm trying to think of how to put them together. So one question is, what's the time frame from deploying a drone and performing a 3D scan to creating the overlay plans, how much manual cleanup did you have to do to get it to be, comprehensible, understandable?
And I apologize, before answering that, we will have some polls up during the Q&A session that we'd appreciate your responding to as we go through the Q&A. So sorry about that. Thanks. Back to you, Mark.
First, a great presentation, Todd. That's a great question, actually. Timing is very critical factor when we do. That's why I call it real time. Because there are, for example, in the Canvas project, you have a factory that's making the boxes so we can meet the schedule on time. Boxing getting made while on site we have erection of steel. So communication is very critical here to communicate any disappearances in real time to our great superintendent or to the factory. What we do typically is that when you fly the drone, so you capture from above all the point cloud and the lasers came from below, then we gather them in point cloud, in Autodesk CAD Pro in the same day. That doesn't take much time with practice, of course. And then after that, the most important thing is the overlays with the drawings as well that was provided from the factory. So this process has to happen in real time. In terms of cleaning or preparing the model, it's use the drone capture with control ground points for accuracy. Make sure the accuracy of the drone capture model is in centimeters, and the laser scan is basically millimeters. We make sure that we compile these models together in Navisworks and in Recap first and in Navisworks together, so it's ready with a cleanup, and you want to care about a certain area of the steel that was erected, and then really the Navisworks overlay has to happen as soon as possible. We did that in the same day, and we had regular coordination meeting with the factory and all the coordination team to ensure we address these conflicts early in the process. Did that answer your question?
Yeah, and I have a follow-up before we get one for Todd. But is all of the drone mapping, laser scanning done on site? And what if that's not close to your office and you still want to keep this as real time as possible?
Yes, definitely. All the clashes. So we had a schedule. That's a great question. The most important thing is communication with the field team. I sit with our superintendent. That's how we work. We sit with them regularly. He has a schedule. I'm gonna erect that steel on that specific date. So I go fly in that date, capture. If I capture it too late, that's not good for us. So everything was captured on site, definitely, and this actually the timing was very critical for that.
Thank you, Omar.
Thank you.
Great. I wonder, Todd, you were nodding your head if you might have something to add to that.
No, I'm just agreeing with everything you're saying.
Great. All right, John, maybe you might have a question for Todd.
Yeah, Todd, there was a couple of questions around the software itself. What versions of InfraWorks and Civil 3D did you use, and were there any lessons learned?
Oh, gosh, lessons. We learn lessons every day. We're really learning a lot of lessons on this Walmart project, especially with the collaboration. We use, so we have an office in Pune, India, right? So it's almost like we stop learning, or excuse me, we stop working, they start. As soon as they go to bed, we wake up, come to work. So it's kind of like a 24-hour process with this. The collaboration on this has really taught us a lot of lessons. Right now we're using 2020 version. We try to stay latest and greatest. However, the way things go in a large organization, it's best if we skip a year. So our next version will be 2022. So we'll be skipping 2021. It kind of messes us up in there a little bit because of the 3-version compatibility. 1 year, or excuse me, one cycle would be 2 versions with the same drawing format. The next time, like our next 2020, it'll be one version within that 3-version drawing format. So it's a little bit of a challenge there, since the backward compatibility is only 3 versions now. We'll try to use the latest and greatest.
Thank you, sir.
Aaron, I'll pass it back to you. Any other questions?
Oh, sure. So this is kind of a different take on the question. This one be for, let me see, I'm going to find somebody who's still here. A person just left. Now, I think it's a good question. So, Amar, what is the process you use for learning? So in other words, do you have like an employee or enterprise-wide learning program? And let me add to that another piece. What kinds of engineers, for example, are using the scanning, or what kind of qualifications do those people have?
That's a great question. It's first, of course, at Windover, it's an acute learning. For example, I learn new software every 6 months. At Windover, we have a program to have, young professionals who want to join to become project managers or superintendents. That's a great program for learning across the company, all the great things we do. For technology-wise and BIM, it needs more of like the accumulation of the knowledge, like learning about mastering virtual reality first. You see here, all the technology, each technology is powerful by itself, like virtual reality or drone mapping or laser scanning. But really combining them together in a meshed process is what may offer a real life solution, powerful solution to challenges on site. So it's an accumulation of learning. If you mastered virtual reality, augmented reality, drone mapping, laser scanning, we make sure we develop this power knowledge in-house and master all these softwares. And then in a very harmonious way, we mix them together to support our field in the team and offer real-life solutions. That's the case. So it's an accumulation process to learn about all of that. And in terms of engineers, we like our laser scanning process is handled by our BIM in-house team, which because they are the guys who process the files later and know exactly what to capture on site and what could be done in terms of overlays and creating models later. So we handle all of that in-house with our BIM VDC team.
Can I add to that, Amar? Would you mind if I add? We actually do virtual reality here as well. The big one, really our first big one that we started with was the Los Angeles Rams Stadium. We're fortunate enough to have a development team here at Walter P. Moore as well, which developed the interface for the virtual reality, which was really cool because you could see what it was like to experience the football game in any seat in that whole stadium through this virtual reality interface. It was really neat to be part of that.
Great, thanks for that, Todd. Again, for the audience, just launching a poll here while I pass it back to John to dig up yet another question.
Yeah, Todd, I've got a question for you. Kind of a fun question. You showed the car there that you were using your Xbox controller. Where did that car come from? How was it built? And kind of give a quick synopsis on the process.
Sure, great question. It's very easy, actually. You would export your model out of InfWorks as FBX, bring it into 3ds Max Interactive, which used to be Stingray. But that is a template that's inside of 3ds Max Interactive. So I didn't have to really do anything but delete some stuff out of that template and then build my model on top of that. So you need to know how to add, what do they call it, gravity, can't remember off the top of my head. Basically, it's so your car doesn't fall through your model and keep going for infinity, right? So you need your gravity, drawing a blank, but there is a great workflow on this out there by Andy Carter. I believe he's got some Autodesk University training on that and the on-demand stuff. So that's where I learned to do it, was from Andy Carter, and it's a very easy workflow to do. You can learn it really quickly.
Thank you.
Great. Thanks. We still have a bit of time here, so Aaron, anything else jump out at you?
Yeah, okay, there's a lot of questions, so if you see a delay, it's so I would throw this out. Can you, I guess again for Amar, can you clarify your workflow in the design and engineering phases? So in other words, the early stage workflow to develop these 4D visualizations. Like what do you use? How does that process work?
Sure. So 4D animations in construction, as we do it in Windover, it's a storytelling. We help communicate to trade partners, to our teams, and to the client how we would, how the project would evolve through the different phases, from foundations, safety planning, logistics planning, fence lines. We work on a lot of prestigious New England schools that's occupied while we work. So we make sure we build safely and define different zones in different phases. This is occupied, this is where the students will go safely while we do our work. So it helps really tell the story. And we utilize with that, we basically create all our models in Revit, because that's, as I mentioned, everything starts in Revit, very detailed. We develop that in-house with our modeling, and then we take that into 3D Studio Max in a similar manner, similar as Todd mentioned, which was great. We create a timeline in 3D Studio Max to help tell the story, animate the cranes, animate the people, animate the steel and the foundations, and to help tell the story from start to finish. And along the way, safety planning, logistics planning, and sync that to schedule to help communicate schedule plans. And that starts with the BIM in-house, our Windover BIM team sitting with the project manager and the super to help get all the information in terms of logistics and schedule as well. So it's a visual schedule, and it's been very instrumental in communicating, especially for folks who are not familiar with construction, like clients, to visualize how we will approach the project, as well as our trade partners that we put on the trailer screenshots or on the screen. We have on our trailer screens to communicate. That's what we built yesterday, and that we will build tomorrow. It really helped our labor to visualize what's the next in terms of boring of sequence of foundations or many things. So 4D is a big part of what we do every day, and we couldn't be really possible without Revit and 3D Studio Max.
Thank you.
John?
Todd, remind me, you guys have started a drone program, right?
That's correct. Yeah, I actually did some demoing for them because I have a drone myself. I did some demoing for them, showed the capability of what we could do. I'm not hip to getting my pilot license, so I don't want that responsibility here. So we developed a list of vendors that can now fly these for us. So it's just a little easier, and plus it puts the burden on them instead of us here in the office.
Okay. Mar, if you'd like to answer that, you can do that too.
Yeah, speaking of drones, we embed also drone captured maps. Like when we approach a project, we don't necessarily need to model the entire campus. What we do is that we capture the entire campus with the drone and take it to recap photo, process georeferenced pictures from the drone to create an accurate representation of how the campus looks right now. And then we add that in the 3D Studio Max to support the story of the 4D animation. So that really adds another realistic dimension to our 4D story to tell.
So what, Amar, what is the estimated cost of implementation of scanning and drone technology?
Sure, that's a great question. Here is the thing. It's not, in my opinion, it's not about the latest drone or the latest scanner. It's really about what we will do with the data captured with both. So even if you have a certain, a moderate drone or moderate laser scanner, it really doesn't matter. You definitely need the accuracy needed from the equipment, but also the value is in how we would process these data to offer real-life solutions for construction and design. In terms of cost, we have Recap Pro, which is very reasonable priced for all the great things we can do with it. And it's the cost of the drone and our time. It's really heavily on how we mastered it to do this very efficiently, quickly. As I mentioned before, time is critical. You scan something in the morning, you have to have the result for your field team end of the day so they can make a decision. So it's really, you can't really track the cost of that. It's even bigger than the cost. It's more about the value of what you do with this data you capture.
How about
Great.
one last question from either Aaron or John?
Yeah, I've got a question just around the modular piece of this. So did you use your BIM model directly in that, and or is that helping you reduce cost?
Sure. With the modular aspect like Canvas, we had to model all the plumbing for the first 2 floors in Revit. You have the steel structure, which was provided by the design team, and what really we were helping with is creating, basically when we fly the drone, you have a point cloud of what's above, and the laser scan from below in Recap, and we take that to Revit, and we basically tracing this point cloud to create accurate representation in a Revit model, as I showed in one of the slides. Accurate representation, basically tracing what we had in Recap in Revit to make the vertical, the steel as-built on site. So we make sure we're coordinating with as-built steel, not drawing steel, which make a difference. So we mitigate any risk. We make sure we are coordinating the boxes with as-built steel, not the drawing steel. So the process with that was we definitely used the models. We keep adding to the model. It's a live document that keeps fed in the Revit model with the information as we build. So basically you have a model and you keep adding to it the steel elements that getting as-built and tweak it to make sure it's an actual representation of what you see in the field and communicate it again in real time.
Great. Thanks, Amir. Todd, any final words?
No, I just want to thank Autodesk for this opportunity to present to everyone. Very much appreciated.
Great. Now I want to thank both of you again, Amir and Todd. Thank you so much for sharing all of the great examples through your projects. And for everyone, if you want to learn more about the AEC collections, you can visit the page here at autodesk.com/AEC Collection. And do check out upcoming and on-demand webinars at autodesk.com/AEC/webinars. And this information will be copied in the chat box. Again, thank you so much to our presenters today. Thank you to the audience for attending today's webcast. That concludes our presentation for today. Thank you so much.
Thank you, Bobby. Thank you, Autodesk. Thank you, Todd.
Thank you, Amar.